Hi everyone, this is Santhosh Kumar. Welcome to MAXLOGICALS. Today I discuss the one question. This question is asked in JEE February 2024 in first session. Let's see the question, that is let f of x equal to cos inverse of 1 minus x, a fraction of x square, and sin inverse of 1 minus fraction of x divided by fraction of x minus x fraction of x whole cube and x when x not equal to 0. Then we are finding the limit of this function at x equal to 0. Then we are find the final answer. We are finding this 32 by pi square L square plus R square. Here L square is left hand limit and R square is right hand limit. Now we are finding the right hand limit, that is right hand limit limit extends to 0 plus where cos inverse of first thing, here we know already what is the fraction of x. The who don't know the what is the fraction of value of x or fraction of x, what is fraction of x. Already I posted the one video on fraction of these functions, so please see that video also. I told one simple thing, that is the value of when we are finding the right hand limit, the fraction of value x is x, fraction of value of x is x. When you are finding the right hand limit, the fraction of x is 1 minus x. 1 minus x. These two things are keep in your mind. Now we are substituting the fraction of x means 1 minus x square, and sin inverse of fraction of x 1 minus x by what is the fraction of x, x minus fraction of x cube, where limit extends to 0 plus cos inverse of 1 minus x square sin inverse of 1 minus x by, we are taking the common x in denominator, 1 minus x square. The limit extends to, now we are substituting the 0 in this function. What happens, we are substituting the 0 in this function where cos 0 1 minus 0 1, where when the cos function is get 1 is 0, and sin 1 is pi by 2, and here 0, x value is 0, 1 minus 0. We don't have problem of these two functions, so we are dividing the functions, that is limit extends to 0 plus cos inverse of 1 minus x square by x, limit extends to 0 plus sin inverse of 1 minus x by 1 minus x square. Now we are finding the limit of this function. Already you know what is this limit of this function is pi by 2 into here we get the 0 and 0, we get 0 by 0 function. The function is in the form of 0 by 0. Compulsory we will move to the L'Hospital rule. That is, what is L'Hospital rule? L'Hospital rule means we are doing the numerator and denominator individual derivative. First, what is the differentiation of the cos inverse of x minus 1 by square root of 1 minus x square. What is the value of x? Value of x is 1 minus x square, and we do the inner derivative also, that is minus 2x. Into what is the differentiation of x is x. That equal to pi by 2 limit extends to 0 plus 0 plus 2x by square root of 1 minus square root of 1 minus 1 square plus x square whole square, that is x power 4 minus 2x square. Now limit extends to 0 plus 2x by 2x by square root of x my 2x square minus x power 4. In denominator we are taking the x square common. What is the value of root x square is x. Now limit extends to 0 plus 2x by x square root of 2 minus x square, and x and x is cancelled. Limit extends to 0 plus 1 by 2 by square root of 2 minus x square into pi by 2, that is pi by 2. Now we are substituting the value of x is 0, that is 2 by root 2. Here 2 cancel, that is equal to pi by root 2. Pi by root 2, that is what is the value of RHL is pi by root 2. The value of right hand limit is pi by root 2. Now we are finding the left hand limit, that is left hand limit extends to 0 minus cos inverse of 1 minus, already you know fraction of x value is 1 minus x square, 1 minus x whole square, and sin inverse of 1 minus x by divided by 1 minus x and minus of 1 minus x whole cube. Now limit extends to 0 minus cos inverse of 1 minus of 1 minus x square, 1 minus x square 1 square plus x square minus 2x. Here 1 and 1 cancel and 2x minus x square. This is 2x minus x square. Here sin inverse of x by divided by, we are taking in denominator we are taking the 1 minus x common. 1 minus of 1 minus, already you know what is the value of 1 minus x square, that is 2x minus x square, 2x minus x square. Now we are substituting the value of x is 0. Here we are substituting the 0. First in denominator we are substituting the 0. 2 into 0 minus 0 and 0 minus 0 0, and cos inverse of 0. What is the value of cos inverse of 0? Pi by 2. Pi by 2. Sin inverse of 0. Sin inverse of 0 is 0. We get 0 by 1 minus 0. 1 minus 0 1 and 0. Here we get the 0 by 0 function. First we can do separating these functions. How separating these functions? When the function is 0 and when the function is a constant, these two functions are separated by limit extends to 0 minus where cos inverse of 2x minus x square by 1 minus x into limit extends to 0 sin inverse of x by 2x into 2x minus x square. Limit extends to 0. What is this function of value? A cos inverse of 0 by 1. Limit extends to 0 minus sin inverse of x by 2x minus x square. Cos inverse of 0 means cos inverse of cos pi by 2 where limit extends to 0 minus sin inverse of x by 2x minus x square. Now we are cancelling the cos inverse and cos, or pi by 2. Here we get the 0 by 0 function. Now what can we do? We can apply the L'Hospital rule. What is the first we are taking the common x in this function. Limit x tends to 0, sin inverse of x by x. We are taking the common of 2 minus x, where pi by 2, limit x tends to 0 minus sin inverse of x by x, limit x tends to 0, 1 by 2 minus x. Here pi by 2, what is this value? That is 1. And what is this value? 1 by 2, that is pi by 4. Okay, left hand limit is pi by 2, pi by 4. Get it, all or get it. Where pi by root 2 is the right hand limit, and pi by 4 is left hand limit. Now we are finding the 32 by pi square and L square plus R square. 32 by pi square, pi square by 2 plus pi square by 16. That is 32 by pi square. In numerator we are taking the pi common, 1 by 2 plus 1 by 16. Pi square common, pi square is cancelled. Where 32 16 plus 2 by 32, 32 cancel, and 16 plus 2 is 18. The final answer is 18. I think all are understand this question. Who don't understand this question, please comment in comment box. Please do like, share and subscribe. Thank you for watching this video. Thank you to all. Let's meet tomorrow.